Ole from Trifork.
And I'm Simon from Trifork.
And we're interviewing Nat Pryce and Steve Freeman at the GOTO conference.
I'm Steve.
I'm Nat.
Yes. So maybe you could introduce yourselves. Who are you and what have you done?
We wrote the book Growing Object-Oriented Software Guided by Tests together.
Often apart. We're both based in sort of part of a very strong London agile software XP community, and a lot of that material came out of a group called the Extreme Tuesday Club, which is now in its 12th year with no visible means of organisation. But there's a long history of I guess a group of people in London that are interested, tend to be the sort of people that stumble into this sort of thing.
Yes.
And this is what we've been doing for a while.
And having read your work, it's almost like you're Siamese twins.
No.
You do a lot of stuff together, don't you?
We did, yes.
Yes, we do a lot of presenting together. We have developed a couple of open source projects for test-driven development together, and then obviously we wrote
Which
together.
projects?
We wrote JMock and Hamcrest, which is a library. The JMock is a mock object library, and Hamcrest is span out of that and became more widely used. And it's used for it's a set of predicates that can be composed and can describe themselves. So it's very useful for testing because you can describe what you want something to match, and then when the test fails and it doesn't match, you can describe very clearly what it was looking for and why it wasn't that. And that's been picked up by a number of other open source testing projects beyond JMock.
And interesting, people are using it for non-testing purposes as well, which is not expected.
Yeah, it's been used for sort of form validation and things like that.
Oh, yeah, okay. So most of your work centers around testing and crafts. So how do you see programming as a craft maturing? Is that happening, or what?
I'm not sure most of our work centers around testing.
Okay.
That's the visible bit.
So it's. I think mostly of you guys as the testing guys. So you're not too
That's not how
keen of that. So how do you see?
I guess the work I do is I usually help or join projects and work on them, helping people often learn TDD. But it's not so much a testing discipline as a sort of analysis and design discipline that comes up with a lot of tests as part of this process, but also drives the design of the software. So software architecture is also something I'm very interested in. I guess just software development as a whole. I don't know about the craft of it, and that whole software craftsman thing is something that I don't know. I wouldn't say I'm really part of that movement, but I sort of see it happening around. So there's an overlap in London between the Extreme Tuesday Club and a lot of the agile groups, and also the software craftsmanship movement, but also with a lot of the media startups and things like that that are also going on. They are very much involved in that side of things.
Yeah, and I think exactly. It's what it's really about. A lot of this stuff is design, and often when I go into groups, I find the reason they're struggling with test-driven or whatever it is because not because they're perfectly capable people, but they missed, particularly the generational thing. They missed the bit where you go to the OO design, and particularly certain schools. And we tend to follow the sort of the route that goes back to Alan Kay that says it's all about messages. And I guess it's also partly because we both have a bit of background in distributed systems. It's all about protocols. And so that's kind of how we tend to see things. Less so, and where if you think about it in terms of the other way that objects are taught, in terms of classification, it doesn't work so well for us, at least for the kind of way that we work.
Yeah, because that's normally when I look at code you do in your blogs and stuff, it's like you create loads of classes, really small and focused and readable classes, which is nothing like I see in professional life.
Yeah.
So why do we normal programmers end up with these huge classes, mother of all classes, that we can't break down? What can we do about it?
I think maybe it's a fear of adding code. Matt Wynn, who's one of the Cucumber guys recently, wrote that he's looking. Kent Beck came up with a classification of like design style. You can have a very connected design style, and that allows you to make progress without worrying about design so much. you can have a modular design style where you have to then worry about how do you compose and then decompose and then recompose things into a system. Early on in a project, the sort of connection styles allows you to make rapid progress, but then as it gets bigger, your system becomes harder and harder to change, and you need to move to a more modular style. So Matt was experimenting with that in Ruby on Rails and was finding that he had to add a lot more code. And I sort of commented, well, yes, you do, but you have to think about a lot less of it at any one time. And I think there's the fear of adding code that people talk about carrying cost of code, but that carrying cost is not all the code. It's only the code you have to read in order to make a change that imposes that carrying cost. And the less you can read to make a change, the better. So I think maybe it's a misplaced fear of adding code to a system.
But also, there's also a thing about it being in different traditions. So, which actually is, I think, is perhaps a more interesting aspect of the craft. To the craft thing, which is, I mean, for disciplines that I know of, where you have real craft, is you know who you train with, and you know who they train with, and and there are different schools, and they all disagree with each other. And I feel more, I think, to some extent, certainly some of the struggles that we've had trying to get the word out is because we've been dealing with people who are from a different school, and they just don't know what we're talking about because there's this mismatch. And I think that's part of, in the good old days, you had to be a journeyman and you had to go from shop to shop because you had to learn different things. You weren't supposed to stay with one master and go all the way through. I think perhaps we miss a lot of that. Thought.
So how do you feel it's going? Maturing programming. We as developers, are we actually getting any better? There's a lot of focus on doing stuff right. You write blogs about writing proper code and all that.
Yeah, it's just. I was thinking a lot about. I would be a perfectionist, but I'm not good enough. But,
I think that there is certainly been advances in what programmers focus on over the last 10 years. Technically, there doesn't seem to be a lot of great change since XP and Agile sort of took off. But in the sort of immediate programming, it's certainly like huge scales, that kind of thing has had a lot of advance in it. But I think that things like lean startup and stuff has focused people on making sure that they can program the right thing rather than something right. And I think that that improvement in sort of marrying sort of like technical changes to your system to better understand how it's behaving, how it's achieving its goals is an improvement that's happened over the last few years.
I think the big thing is that it's now respectable to talk about testing and to make it a first class part of your process, even if it's very few places actually do it rigorously. But at least you can now talk about it, and there was a time when people didn't even talk about it because it was too low status, unfortunately. So I think actually that's probably the biggest thing that came out of the XP, or one of the biggest things that came out of the XP world.
And I think we're seeing a lot more stuff coming out of academia now for empirical software engineering. I think that's starting to pick up, hopefully. So, I mean, it's a very difficult thing to study empirically, but some interesting results are coming out of that. And they, often tally with your sort of hard-won intuition that you've learned as an actual, on-the-job programmer, and sometimes they're quite surprising.
Do you have an example of
So, a study recently found that integration defects are correlated with the distance between the groups who are producing the modules being integrated in the organisational hierarchy, which is sort of, I guess, an empirical support for Conway's law. Right?
But the thing is, it's not about physical distance; it's organisational distance. Which is not quite which is a nice finding. Yeah. So things like that can that's coming out of the academic empirical software engineering community can directly influence, and influence your sort of like day-to-day work, because you immediately can see on a big project, well, if you've got a vendor relationship, then you're going to have to focus on the module interconnections between your code and the vendor code, because there's a big distance organisation between those two things. Or even if this group is sitting over here, it's very hard to get them to do something because
only drawing up at the top of the corporate tree, for example. So then you can focus your technical testing and design effort around that. That kind of thing I think is good, and more of that is coming up. I see a lot of empirical software engineering stuff coming out of the ICSI conferences, and there's more blogs about it now. There's some great books by Greg Wilson on the subject, and he's done some great talks which you can find on YouTube and stuff. So all of that I think is it will improve software engineering a great deal, I think.
The other big shift from this period has been the postmodern programming line, which is the scrap heap approach to programming, where basically it's bolting bits and pieces together off the internet, for good and bad. And there's some good aspects and some not so good aspects. But again, that's in my earlier days. There was a time when we didn't do that because stuff wasn't on the web. The web wasn't on the web.
Yes, Google. I mean, God, how can you program without Google?
Yeah,
I used to.
And so in terms of the next generation, they have opportunities or whatever that just weren't available. And things like you can scale if you want, and you can get it off the shelf. And in theory, if you know if at some level you know what you're doing, you can do something very. You can just focus on the bits that you need to, and then everything else just kind of spend the rest of your life debugging, I suppose. Which is the downside of that, and you don't have to write.
So I'm testing.
Yes. So the world has changed. The downside is that often, if that's the only thing you know, it's very effective, but only that area, and then a lot of other stuff they haven't had time to find out. And that's the other thing is that's why it helps if you've been through a few technology cycles, because then you get bitter and twisted.
Yeah, because that's also the functional movement. And I kind of sense that they don't treat testing quite as seriously. It's just my sense, and quotes like "mocks are mocking you."
Well, that's widely misunderstood techniques.
Maybe.
Yeah.
But last year we had this programming with the stars where all the people programming in functional languages, they had their REBL and they just messed with that, and they got some result and they pasted the code into their application. So do you think there's some different view on testing in the functional world? Or?
I think there is. I think there's always the hope that the type system, the next great functional type system, will solve everything.
But Clojure is typeless.
Clojure is typeless.
Dynamic
but,
types.
the Haskell world is moving towards dependency, dependent types. And like a great type system really does get rid of a lot of things that you don't always have to test for, right? And it's much better to, and this is something we're coming back to design again, right? It's much better to build your system, design your system in such a way that you don't have to test for certain things than it is to test for them. So not having tests and not needing them is a lot better than having good tests. It's something that otherwise you could just not ignore. And so, having completely stateless code means you don't have to test for state changing and the aliasing effects and things like that, which is a great thing.
But I think it's another important difference, which is the people at the core of that, the core of the functional movements, they're dealing with the fundamentals. And that's, I think, perhaps...
It's S-type
system. Well, it's more susceptible to just sort of thinking very hard and then typing it in. And a lot of the systems that we build are full of really messy, not real world, but human-designed environments.
Yes, where the code is part of the environment and affects it as soon as you deploy it.
What I mean is that the domain is very messy. So it's hard to come up with a clean model of some of the horrendous domains that people have just grown over the years. And so
you say that, but then the Haskell guys did. Simon Peyton Jones did go and model financial contracts, which are extremely messy.
But at the bottom of that, the bottom of that was like this virtual machine for finance. But on top of that, the actual trades, you can't be that clean.
I think there is, I think OO style, which is what we write about in the book, and functional style they're not incompatible. You use them in different places. A lot of systems I write, when I can, have as much control as I'd like, have a lot of purely functional code. Even in Java, even though functional code is quite ugly in Java, it still pays off to avoid mutability. And then there's sort of you can still use polymorphism in your functional code to get the benefits of that. And then you can have sort of event-driven tell-don't-ask-start-OO at the sort of lower layers, which are handling the events that are driving the system, but those events are then being serviced by objects which then perform functional calculations to calculate the outgoing events. So it's a very clean architecture.
Yeah.
Easy to test at different levels.
I mean, that's more or less what we did with the example of the book. It was a long example, but not as long as it should have been, because there was a lot more we wanted to do. But we
ran out of time.
We ran out of time and pages. But within that, there's an awful lot of that which is immutable, which is actually little functional transforms within a larger event-driven wrapper. And you just keep moving in that direction. The other thing is that the VM has got so much better, so that you can actually treat little transient objects as disposable and not worry too much about the cost in the kind of systems that we mostly built.
So in general, what kind of problems do you see when you go out at clients? What are the biggest mistakes projects do? And if you have something like the biggest mistakes, is it just new problems every time you go to new projects?
I think what I see a lot is, one thing is people don't spend enough time maintaining their tests so that when they fail they can actually understand what's gone wrong. And that's both like maintaining the readability of the tests, refactoring the tests so that the right testing abstractions for your system pops out of the refactoring of the test code, and just ensuring that they're sort of consistent, easy to understand, and also working on the diagnostic so that when a test fails, it explains clearly what's gone wrong instead of just a huge stack trace and a bunch of thread monitor dumps and what have you. So that I think is really important. And I think the other thing is not so much about testing as that people don't take Conway's law into account when they're designing their systems. So often they'll have, for example, they won't have any sort of like clear interfaces between teams that are on either side of each, opposite sides of the world, and they only talk by phone every morning, right? And so it's very hard to collaborate on a shared code base with people, and then it's very hard to get on top of the sort of like design flaws that start sort of coming into the code, and then like getting to a common understanding of the direction the code should be moving in, and getting everyone to move it. If you only ever talk to people for half an hour a day over a crackly line, and so thinking about your architecture and organising the work up according to your communication bandwidth between the team members and between teams, I've seen a lot of projects where that doesn't happen. It just degrades over time as a result.
So it's actually a lot of process gone wrong, and not necessarily technology gone wrong.
Well, I don't know if there's really much of a difference when it comes to software. It's just about organising your work in such a way that where you have to agree on things, you can agree on as little as possible. When you can't have a lot of communication between the people who have to do the agreeing, I think. So when you do split your team up around the world, you have to do more upfront design. You can always change it later, but it's very difficult. It becomes more and more difficult to change later the further apart, the more sort of distributed teams you have. So the way you design code changes depending on how closely people are able to work together.
In fact, I think it's something Rachel Davis once said. She sees a lot of teams that just don't talk enough. XP teams where they don't talk enough about design, they don't step back enough. They're so. In fact, I think one of the failure modes of certain kinds of agile is this sort of value fetish, where if I'm not typing code in right now of value to the customer, then it's obviously waste, and we must stop doing it. And it's very hard to step back and look at the real economics of the situation. And you look at a lot of teams where actually they've been so focused on oh my god, we have to survive this week, which may or may not be true, that they haven't looked at the next level up, which is actually it's costing us a fortune, and the next level up, which is oh my god, look how much time we're wasting, and they're too busy just pushing forward and getting the buzz of making progress, which is you need to do, but you also need to step back and think about perhaps a larger picture. And I think one of the other things I see increasing sort of getting wound up about is, you know, over the years I've been very lucky to have been on, you know, worked with some very good teams. But what I see is, again it goes back to the craft thing. I see a lot of people who've never worked on a good project, and you can go through your entire life in this business, and always work on rubbish projects, and you just, you know, you might have an inkling, but a lot of people just don't. A significant proportion of the people I bump into just don't know what it could be like. And the tricky bit with a lot of the stuff, some of our experience, particularly when you go, for example, full on hardcore XP with all the test driven and the full refactoring and all that stuff, is that the quantitative experience takes you to a different level. And it's very hard to talk about that if you've never experienced it. People just don't believe you because it doesn't make sense in that world. And they don't see the point of putting all this effort in because that's just waste. And I'm not sure how to get that into the world. Maybe it's never going to happen.
I do work with, I have worked with a lot of programs who are not lazy enough, as in, you know, quite happy to do lots of repetitive manual work, and instead of just, you know, automating or avoiding work, or, you know, writing the test so they don't have to spend ages debugging and things like that.
Or just step back and say, why am I doing this stupid thing? You know,
and so there's a certain laziness that you need to foster in programmers, which as a result makes a project much easier to work on. It seems, if you're not used to working in that way, like Steve said, it just seems like an alien language you're speaking when you're trying to explain it. But yeah, I mean, I much prefer to work in that lazy way and have the computer do most of my work for me.
So what you're saying is basically when you get into this reactive mode, it's pretty hard to go back into the proactive.
Yeah, so it becomes very, very difficult to avoid it.
And because the other thing is that what happens when you're in the mess on this side of the curve is you put all this work in and you can't see any difference. Because and so often what happens is sometimes what happens when I start with a new team, the first thing I end up doing is fixing the build. And that generally involves me sitting in the corner swearing for 3 weeks. It's so unpleasant. So whoever's dishing out my fees going, why am I paying money for this guy again? Because there's no for all these guys, there's unpleasantness and no visible benefit. But what's actually doing is trying to get the risk down. And you see teams that where they have this massive hidden risk that they can't see. And again, unless you've seen it somewhere else, it's very hard to talk about it in the abstract. And if they've been ticking along nicely and haven't had the crisis, well, we're fine. What's the problem? And I don't know what the tools are to
well, more often they'll never have a crisis. They'll just
you might be right.
slowly, you know, continue at a low level of mediocrity. And often that's what people think. It's like, well, all software has bugs. You know, it's quite usual to have lots of bug fixing at the end of a project. I don't like working that way. You know, too lazy.
Well, again, and I know a pal of mine who worked on a project where a couple of times they were an hour away from £1 million losses because they would have missed the overnight batch which would have kept them solvent and all the rest of it. And they go, well, we caught it, what's the problem? Someone happened to be watching the logs at the right time. And it just seems to be impossible to get through that actually, you know, this might not be the best way of proceeding. And I just don't know what to do.
Scary stuff.
Yeah, it's not often, but just.
Well, I've run out of questions, so thanks a lot and have a nice time at the conference.
Thank you.
Thank you.